Good morning, good morning. Still a little loud. Let's try this today. I got some feedback that the music was maybe a little bit loud or a little bit quiet. So I'm gonna try this setting here. At around -45. Actually, wait, I can see exactly where it is. It's at negative 35. -35. I'm gonna write that down. 35 dB music. I'll check out the VOD later, see how I feel about it, and like spot checking in different areas. Or if it's too loud, let me know too. All right, what are we doing today? Today we are looking at derived macros. So I want to be able to basically understand how Strum, the crate, works. But I'm not going to go actually look at their source code. I want to actually figure it out on my own, because I think that's going to help me in other situations where it's not like explicitly what Strum is doing. I can then have the confidence to do that myself. So this is a derived macro. Let's go through, like, let's create a situation here. I don't need our main library anymore. How did I delete source? I did not want to delete source. RC. Oh, RS. Okay, so I want a main. We don't have to return anything here. Let's just try our command line just to make sure that we're still good to go here. And we are. Perfect. Okay, so what I want is to be able to create an enum. So we have an enum. That enum will be something like names. It doesn't really matter what it is. So it could be anything like components, whatever. And then we could have something like location, size. Let's see. What else? What other things? Oh, I like maybe hit points. These could all be potential component names. Because when I use BBECS, it wants to take in a string or a stir at times. So I want to be able to use that myself. Now, if I were to bring in Strum, I think that's actually relatively easy for us to do. I think it is just Strum, right? Yeah, Strum, okay. So Strum here, if we look at how we have to bring in Strum macros too. Strum underscore macros. You can also use the derive feature and import the macros directly from Strum. Oh, okay, this is what I want to do. That's what I want. Okay. Once Rust Analyzer is done, then we should be able to derive. It's like into string, like toString. And that's what I want to do. Is I want to be able to derive toString here. So I should be able to do something like use strum to string, then I can derive to string. Then if I want to, like, I can just debug this out. So debug, we could do component names, location, to string like that. And there we see we have a toString is this location. Oscar Ellen, hello! The Macro King is back. I wouldn't call myself the Macro King, but I'm certainly trying to learn those skills. How are you doing this morning? I know it can be evening, afternoon, whatever for you, but how are you doing today? So you wouldn't call yourself that yet. I would never also call myself the king of anything. I always felt that's for other people to assign those names. Okay, so I want to do this. This is the example. I want to be able to create this so I could run this myself. So it is a good time of day. Yeah, absolutely. Okay, so how do I end up doing that? Let's go take a look at the book. Because I think Wrestling Chapter 19, I want to say, has it. Macros. Okay, so there's macro rules. That's what we did the last few days has been macro rules. Procedural macros are generating code from attributes. So we want a custom derived procedural macro. That's what we want. When creating procedural macros, the definitions must reside in their own crate with the special crate type. Huh. This is for complex technical reasons that we hope to eliminate in the future. Okay, using procedural macro. Okay, so I get using procedural macros would be exactly like that. So that's what we want to do. Okay, so how to write one. Okay, so we're going to create a new library module. We're going to create a new library module. Okay, let's go do that down here. Cargo new lib. And then what are we going to call this? We can call this like BB. All of my crates are namespaced for Brooks builds. So Brooks builds macro strings. I can just do Brooks builds macro strings. Let's create that. Oh, new version of Rust Analyze. Oh. Aw. Okay, I'll try it again later. Bootstrap error. It's not actually web development bootstrap error. I'm sure it's something else. Okay, so We create the new library. Then we're going to define the hello macro trait and its associated function. Okay, so we have to have a trait. So we're probably going to just name this the same thing, which would be like a toString. And this also sounds like it has to be in the live.rs. I don't actually know if it has to be in live.rs, but we'll find out. So we'll have a pub trait string function. So this one has function hello macros. This would be to string like this. And you're going to return a string. All right. At this point, our crate user could implement the trait to achieve the desired functionality, like so. Oh, right. Yeah, we could just do impl hello macro for pancakes. Yeah. However, they would need to write the implementation block for each type they wanted to use hello macro. We want to spare them from having to do this work. Very cool. Hello. Good morning. Additionally, we haven't yet provided the hello macro function with default implementation. Right. Okay, so no, we need to create another one with the derive. So, cargo new this thing, scooby macro strings derive. So then we create a derive. Our two crates are tightly related. So we created the whoa. Within the directory of our hello macro crate. Oh. Hold on. So I want to cd into here and do a cargo new lib that. Then this, we don't need you. We need you, and we see, okay, here's their macro strings derive here. If we change the trait definition in a hello macro, we'll have to change the implementation of the procedural macro. Yeah. The two crates will need to be published separately, and programmers using these crates will need to add both as dependencies and bring them both into scope. However, the way we've just structured the project makes it possible to use hello macro even if they don't want the derived functionality. Okay. We need to declare the hello macro derived crate as a procedural macro crate. So in the hello macro derive cargo toml, this becomes a proc macro true under lib. So in here, so we have to create a lib section. And I'm guessing it doesn't matter where these are. So just proc macro equals true. Okay. We'll also need functionality from the syn and quote crates, as you'll see in a moment. Really? Oh, syntax, parsing syntax. Okay, syn and quote. Okay, so let's bring those in. To start defining the procedural macro, place the code here into your lib.rs file for the hello macro derive crate. Okay, so let's put this off to the side. Wait, where did that go? Here it is. So this is our derive crate. So we need to do the external crate proc macro. Do we really need to do this anymore? I sort of feel like external crate is not necessary. Okay, so we're gonna have proc macro derive hello macro. That hello macro was the trait created in here. Got it. Okay. We have a pub function. This is going to be essentially hello macro to string. So, hello macro derived. So this will be to string derive input token string. Okay, you're not happy with that. So this is I guess. Okay, there you go. Let's see. Then we're going to return token string. So we do want to construct a representation of Rust code as a syntax tree that we can manipulate. Okay, so we're going to do create an AST. Oh, and we use syn to parse the input. Okay, so let AST equals syn. Parse input. Okay. And then build the trait implementation. Simple macro. So where does this come from? Impl hello macro. Is that from the other file? So all we've made is like, well, where does this function come from? The code you specify in the body of the inner function, impl hello macro, in this case will be different depending upon your, well, of course, I know that. But where did you define this function? Because I see the trait. Because here's the trait. But I don't see like a function named impl hello macro defined anywhere. Yeah, that feels weird. Okay, so let's pull in that trait. So use Lord Mist, hello. We also need to pull in this macro. And I don't see it pulling in. I guess like this is not really a macro, this is a trait. I don't see it pulling in the trait anywhere. I guess extern crate is doing that for us. So can I use a use instead? Or do I have to do an extern crate? And that would give us this crate here. So sure, let's try extern crate. Extern crate. Proc macro is, I think, that's not what we named the other one, right? No, because we named it hello macro. Oh, okay, so macro. We're trying. We're following the tutorial here in the book. I have my doubts, but I'm gonna trust it. So we're gonna have a proc macro derive, and then okay, so this has hello macro. Hello macro is the trait that we created over here. So we want to create this toString. We don't pull that in anywhere, so I don't know how it's going to find it. And then this is... I don't know where it gets the hello macro from. Quadabot, hello, good morning. Okay, so if I import like toString, essentially, and we pass in a reference to the AST and return that. We've introduced 3 new crates, proc macro. Now, we didn't pull in proc macro, did we? No, there's no, proc macro is not pulled in. Unless this is pulling in a new crate called proc macro. The proc macro crate comes with, okay. If I had just read like literally the next sentence, it comes with Rust. We don't need to add it to the dependencies. The proc macro crate is the compiler's API that allows us to read and manipulate Rust code from our code. The hello macro derived function will be called when the user of our library derived. Okay, so this one will be called when a user of our library specifies derive hello macro on a type. This is possible because we've annotated the hello derive. Okay, that. And specify the name, hello macro, which matches our trait name. This is the convention most procedural macros follow. The hello macro derive function first converts the input from a token string to a data structure that we could then interpret and perform operations on. This is where syn comes into play. The parse function in syn takes a token stream and returns a derive input struct representing the parsed Rust code. I mean, so are you telling me that I could essentially just do a debug of a reference to AST here, and then in our other code, here, let's see, we're not going to use strum anymore. Instead, we're going to use BB. So what do we call it? BB macro string, I think. BB macro strings to. Yeah. Okay. We're looking at path. All right, so I think we're just one out. Then we're on to that. And if we need to pull in the other one too, so derive okay. I mean, crates it says is okay. So then in here, you have to pull this in. So use, is it to string, I think. And then here we can do a derive to string. Now we can't do this, I believe. Wait a second. No, you're derived up here. Is that going to, like, if I just do debug the world, aha, okay, so it did try to run it. No token string in the root. A similar name exists in the module, token stream. Really? Okay. And then yeah, this is what I've been sort of like curious about. It's like, what the heck is this? So if I come back here, you gotta remember that you should always use fully qualified names in macros, as the imports for the macros expands aren't always the same. Also, you can't use anything from your proc macro crate at runtime. Well, this is what, okay. Is the book wrong then? So in here, I don't want to do any of this stuff then. Let's just take that in and debug it. Token string is the name of the trait the derive is for. Token string. This token string? Really? And you don't want to make a proc macro that derives token string. You want to make one that derives resource. Wait a second. I guess I'm confused now. So our book is telling us that we need to use proc macro like this. I'm making one that derives toString, yeah. So I have this this trait, toString here. I want to derive that. So you're yelling at me that this doesn't exist here, but if we run you again. Yeah, okay. So now we only have this error now, which is use proc macro token string help a similar name exists in the module. Oh, token stream. I misspelled it. That's my problem. Token stream. Yeah, no, did I just completely? I did. I completely misread that in my brain. I'm thinking strings, and they're similar spelling, I guess. Okay, so let's come back to this. Try you again. Expected struct proc macro found nothing. Right. That's because we didn't actually return anything in here. So this, I don't understand where this is from. Like this impl hello macro, because this isn't like a. So if I do like an impl to string, and then pass it in a reference to AST. Impl hello macro is literally the implementation of your macro. I don't know if that helps me right now. Like understand it more. Because like, what is it doing? Like, it's the implementation, but I'm calling it as if it already exists. Don't I need to create it? At least with like the other type of macros, I could sort of like wrap my head around, like I'm creating this that generates out. With this one, it's almost like, I don't know, because what it returns is the code, usually a trait implementation that'll be inserted. Where is, okay, whatever. I'm just gonna try to run this. Like, I can't imagine it's gonna work, but yeah, okay, not found in the scope. That's kind of what I expected. Are you doing this thing, book, where you're like telling me all this stuff, but then it's not ready yet because I have to go write it? Return token stream new. Okay, let's do that instead. That sounds better. So we're gonna return token stream new. Consider giving AST a type. So you're turning the empty token stream, meaning your macro expands to nothing. Okay. Okay, so I have to give AST a type. Finally, here's where it is. Like, I don't know. So this is a problem that I have with most like programming books, is they try to give you all this theory up front, and that's not how we learn. We learn by doing, and then theory comes afterwards once we have the context. So I kind of wish they just gave me the code to write in, have it work, and then go through like all of what it's doing. because I want to be able to run this as it's happening to sort of like explore it on my own. But okay, so here we're going to create this. This is in the hello macro derive lib. So here we are in the hello macro derive, or we're in our derive lib. So now we can create this impl. Okay. And is it public? It's a private function. So function, this is the toString. Oh, macro. Wait, is that impl hello macro? Oh, it is. Okay, so we want impl toString macro. Sure. This takes in an AST, which is this. That's going to give it the type we want, so it knows what type it is. So we're going to take in an AST, which is a syn derive input. And we're going to turn a token stream. Okay, then this is where we can actually do what we want to do. So let name equals AST ident. Okay, so can I? So gen, okay, we use the quote macro to create this. Okay, so we can, here we can do our, we're going to return a token stream new, or an empty token stream. And here we're going to call that and pass it in a reference to the AST. So I'm curious if that will work now. Derive input doesn't implement standard format debug. Okay. So I can't just look at it like they show us in the book. They show this type of stuff. That's too bad. Okay, so we're able to grab the name out of it and look that way. Why do I keep on making that full screen? I don't want to. So we're not going to do this. Basically, it's just this simple thing here, and then over here. Let's grab the name out. So this is going to be a reference to ast.ident. And then we can maybe debug this. Oh, expected a struct proc macro token stream found nothing. So you are nothing essentially. I want to that. Cannot find derived macro toString in this scope. Okay. So cannot find toString in this scope. So here we have trying to tell you to be toString. Okay, so yeah, they're using. Oh, we need both of them. Use hello macro, and hello macro derive hello macro. Might derive. How am I exporting that? Or is that sort of a thing? So use that. Also use. Ah, okay. They do that by re-exporting your macro into structs module. Okay, so that makes sense. So that exists. Try you again. Look at this. Okay, so hello world is hello world. We get this hello world. We don't get the other debug. We do get the other debug right here. Name ident, component names, span. Okay, so we're able to figure out what this is. Which I feel, did I do that wrong? Should this be ast.ident.name? No, okay, we're getting like the full identifier, which is sort of like that object. All right, so we're able to see this is component names, which is this. So then we can impl. Ah, okay. So then we have this hash name that suddenly is available to us. That's what this quote is giving us. So if I can come back here. We could then let gen equals quote. It's gonna yell at me. All right, so we're gonna do impl. This is toString for hash name. Then we can create the function for it. Our function being just toString, but if we wanted to go take a look at that again, that's right here, this toString. So function toString. We're going to return a string like that. So to begin with, we can just hard code something like hello from the derived macro. We can, who owns this? And then at the end, instead of this token string new, we're going to gen.into. back to here, if we run this, now I want to debug component names, location, .toString. I don't know if it has to be that, or I feel like without the self, it's going to end up being something like that. Let's, oh, I got an error. Okay, this, okay. Thank you. Correct, we know, we're okay with that. Let's actually turn that warning off. Allow dead code. Okay, so we'll go run. All right, so we get this hello from the derived macro. Nice. So if we come back here, if I want to import this, let's change our trait. So you take a reference to self. So now we're going to take in a reference to self. We're going to return a string. We can use stringify, I think, to help us out with this. So we're going to use the stringify macro and pass in self and return that. Let's see what happens. Oh, right, and now because it's on self, we have to run our code slightly differently. So here, instead of this, it'll be like location dot toString, like a specific instance of this. Mismatch types expected, standard string found stir. The stringify macro will literally expand to self. Oh, that's a that's a really good point. I hadn't thought about that. Also, this is a so toString that. Here, let's go find it. Let's actually see what we did. So here we go. Self. Ooh, that's the best. Okay, so stringify isn't what we want. Gotta get the name of the struct in your proc macro and then place that in there. Gotta get the name of our struct. Well, the problem is we want the name of the arm, right? I don't think I can use format for this, can I? So use format. Self, return that. Component names cannot be formatted with the default formatter. Okay, that makes sense. What am I doing? I mean, flailing around. Okay, how do I get the name out of this? I guess like we have the name here, don't we? It's like name.name, I think. Was what it was, but that's the name of the crate and not the name of the arm that we're on. So do we have to do like another AST? Like, how do I get what this is? Because if I debug the derive input, we'll have some way of getting the name, which in quote you got to use in order to create literal that. Right, so I figured out that I need the quote, but if I use like debug, and I like put self in here, and I guess we could just do a like hello toString. Component names cannot be formatted using that. The trait debug is not implemented for component names. Interesting. So I need that here. I guess because I'm using debug inside. Okay, so self equals location. So if I can expand that out, I can get it. I don't think stringify works that way. So if I want to get the name of the arm, then I'm in. Because I want this, not this. And the name that I see so far, unless I can somehow actually like see what this AST is, which I don't know how to do. It's off of sin. Okay, so. Yeah, I have to do things based upon this self that I get then, right? Got to generate a match expression for each arm and then return the string accordingly. Oh, it's just that. Okay, well then that would be relatively simple, right? Maybe, possibly. So let's match off of self. Oh God, love. Now, if I'm trying to do this dynamically, though, I don't know what the self is going to be. So I don't know what this is going to be. So, like, is it just going to be like that? How would I grab this out of match? Because like match normally would be like, okay, self location. No, I'm trying not to cheat. I don't want to like go and just look at what they're doing. I want to actually like learn this. So how would I get the arms? Yeah, no, if I want to just use strum macros, I wouldn't even learn this anyway. I would just always use strum macros. So how could I possibly match if I'm not actually caring about, like I wanted to get dynamically the arms. I also got to worry about generating ... or behind the variable names in a match pattern accordingly for it to be correct syntax. Like, is this going to be something like, can I get the list of arms? Like, there's no iterator off of self, I don't think. But that wouldn't be the match. I can only match once I have the list of arms to do. First, I got to check that I'm even running on an Enum. Well, I mean, that would be proper. The thing that sort of bothers me is that I can't see what I have in the AST. Because when I tried to debug this, it just yelled at me. Let's try it again. Just in case, maybe it works this time. Yeah, okay, so drive input doesn't implement debug, so I can't see what's actually in here. So like I'm flying blind, which is really hard. And even if I try to like ignore that, maybe it will work anyways. Wait a second. I'm in the wrong. Where am I? Where do I need to be? Wait a second. This is exploring Rust macros. Hold on. This is where I want to be here. Then over here, this other one, I want the debug ASD. Okay. That's what, okay. I go run you. Yeah, okay. Cannot be formatted using that because it doesn't implement standard format debug. Debug is not implemented for signed derived input. Do I, does it implement display? Can I just print line it? No, okay, so it doesn't have display either. Maybe there's a method on it to make it a string. Oh, well, maybe, but I could try to string it. So you're no help, Rust Analyzer. Let's try a toString. The debug impl is hidden behind a feature. Oh. Okay, hold on. Let's take a look at this. Oh, extra traits only. Create feature, extra traits only, and this is for sin. Okay, so this one, sin. How do you do this again? It's like version equals u, features equals an array of strings like that. Feels wrong. Maybe? And then if I do that, I should be able to debug AST. Failed to parse Mark. Okay, so, oh, missing a comma? Oh, is that all it is? It's just commas there? Failed to select a version for sin. Okay. Like you're liking that. Versions that meet the requirements, 1070. Oh, the package derived depends on sin with features extra traits only, but sin does not have those features. Look at this. We can actually see what we've got now. Oh, thank you so much, Oscar Allen. Yeah, yes. And I saw that afterwards that there was a space in there. Okay. So here we have our attributes. I don't know if this is going to help us, but it feels like we're moving closer and closer. So here's our identifier name. Data enum. Okay, so we can see that you're an enum here. And look at this. Here's our variance. So if I want to grab this information out, so in here, put you over to the side, leave you right there. So we have our attributes. So ATTRs. This is ident to get the name. So ident to get the name information. If I want the data, that would just be data. So if we do let data equals data, now let's show off what data is. Okay, so here's our data. Enum token is an enum. We can even see that, okay, that is braces that are doing that, and then all the variants, okay. So is this how we can determine that if you're an enum? Is just check to see if what that is, enum token. So if I want to do data dot enum token, what would happen if I do this on something that's not an enum token? Could not compile, no field, okay. So we have the data enum. So, okay, here's data. Data enum. Okay, we can see if this is a data enum. How do we determine if you're a data enum as opposed to a data struct or a data union? Got a match on data? Ah, okay, yeah, that makes a lot of sense. So we come back to this. Probably still want that. We could probably just do an if let, right? So if let data enum, but we need to pull that in. And you are syn data enum. So you're a syn data enum. I don't necessarily care about you. You just write regular Rust code at this point. It's just operating in AST. Yeah, that's sort of what I figured. The only negative is that my I'm not getting good syntax completion, which is not fun. Okay, so if that I don't necessarily care about what you, but we can just put data in here equals data. Then I want you. So okay, if if you're a data enum, then we can just do like a debug. We are a data enum. Else, let's panic. I don't know if that's actually a good idea for us to panic here, but we are not a data enum. Why do this? Why you do this? Okay, so if I do that, run this again. Let's not debug you right this second. Use struct pattern syntax instead. Send data enum. Oh, it has to be the brackets, not this, because it's not a tuple type. It's a anonymous struct type. So we have, I guess like enum token. Ooh, okay. Enum token. Brace token. Variants. This expression has type send data. Why did mine not? Oh, because the enum token is just the literal enum keyword. Probably not too interesting to keep. Yeah, probably don't need to keep you. I was just sort of grabbing them all, but we got another problem. So this expression has type send data and not data enum. So that data, come back up here. The data is an enum with data enum in it. So I wrote this wrong. This is data. Send data. Oh, enum. We could try it. No, it's still not that. Oh, use the tuple variant. Okay, so now we're back to not having this. Now we're on to like whatever this is. You can just say data. Yeah, data enum. Okay, we are a data enum. So we have the data enum now. So if I debug this data enum, we should get all of these things we want to get. Okay, so here is now our data enum. Which means that if I were to create, this doesn't exist, so I'm not going to worry about that right now. But if we have like a struct testing, I don't really care what you are, but we're going to derive to string on it. I would expect, oh, we also have to debug. There you go. It panics right here. We are not a data enum. Why you do this? Okay, Nice, that works. Now this is interesting. Okay, so I just take you out. Okay, so we finally have our data. So we can look at this. Now we can get the variance. Which are through these idents. So we can loop through the variance. So for variant in data enum dot variance, and we'll debug the variant. Oh, you're just yelling at me because we're not returning a string. Sure. That will make you happier. Oh, I don't want to move you. Oh, I don't want to move you. Okay, so now we have our variance. Okay, so then we can get ident. So there's no attributes. It's just the plain identifier. Okay. So let's debug variant dot ident. Just like slowly drilling down inside. Okay. So here's that ident dot ident. Unknown field. So ident is this ident here, and then there's an ident. Okay, let's see. Is there a way to get out? I don't see one. There's an inner, but they're not public. Returns the span of this ident. So I could try a span. All right, okay, so span gives us not that helpful. It's the span of bytes. Oh, that's not what I want. So when we're just looking at ident, we see this. Is this ident? Oh, okay, yeah. Here's span with the bytes in it. Now I can't get ident out of here. I can get. Is it? No, it's not a function because we don't see that like as a function in here. there's hash display wait, one ident. Back to ident. Have you looked at the heap size example in Sin? No. Heap size. Also, just sort of like looking at these examples too. It's like create a new. There's a toString on it. I can do a toString. What does that do? So I can do a toString. Not like that. If I do that, what do I get out? There we go. That gives us location size. Okay, that gives us our things. Awesome. So if I want to now I don't know if well, okay, let's we can do our let mute like arms be a vec and this is just going to be our arms dot push these strings into, and so then down here we now have like what these are. Kim slash hello, good morning, how are you doing? Okay, so if I have those, then in my toString function I would want to do a match. Can I do that with like something like this? So let's see. Name equals that. I wonder if I can use this to like as part of quote. Yeah, it's good to see you too. Well, in text. Let's see. If I want to what if I did something like let like test equals it would be oh, because I don't think I can do something like I don't think I could do something like this, could I? Like then hash like arms of 0 and then debug test just to see like, hey, did I Did I like, you know, grab that one like location, whatever one of these are? I doubt it. I can't imagine this works. I don't want to get the actual string out, do I? I just want these idents. So I just push the ident in. Okay, then let's get like a single arm. So if I do that, then how about you? No. I probably need to go look at it's like name is ident. ASD data, so we get arms, which is this arm, like the first one that gets pushed in here. A local variable, name exec arms. Well, that's not helpful. I want like that specific one. Now, if I do like a debug arm. Oh, you won't even run unless. Okay, so if I take you out. Not found in the scope anymore? How did I break it that bad? Did I somehow... You're returning this. I'm returning you. Expected struct string, found that. Okay, so how is this? Now it's not found in a scope. Did I somehow remove it? No, it's still in here. To string. What did I do in here to like break it? Let's undo all this stuff. Temporary value is freed. Okay, so we have arms. We're pushing into arms. Let's say I don't... Arms with you. Pushing... I wonder if I need to do this inside of the function instead of outside like this. Although since we're panicking, it has to work, but what is that? Arm stop push. Okay, so variant, ident, string, temporary value is freed. I guess we could clone it too, but let's try this. There we go. Okay. So now we have you. If I down here in function to strings, if we just do a debug arms, just to make sure what we got. Oh, it doesn't like this anymore. Because arms doesn't exist up here? Cannot find value arms in a scope, right? Because like it's up here, but like debug arms won't work in here because this is what it's expanding out to be in the real code, and arms doesn't exist up here. Right, okay, that makes sense. I would need to like somehow put it in here at that time. So we need to, this is gonna import to strings, like create them for us. I can do my debug of arms here. Okay, so here's my arms. I can, where do I want to do my loop? To loop through each of the arms. I don't want to do it in here. I want to do it out here. Whenever you think proc macros are hard, just think of poor people who wrote the quote macro. So we have arms here. I don't want to have multiple two strings for each arm. I want to have a single string. And then it deals with this thing. But I need arms to exist in here at this time, but I don't have it. And I think that's our problem. Now we have name here that expands out, but we don't have. Is it gonna be the same thing as like in the other macros where I can do like star to like regenerate stuff? Like, okay, let's try this. Let arm equals a reference to arms of 0. Can I now have like the equivalent of, well, no, let's do that. Let's try it. Can I debug hash arm? Arms has type, which does not implement the copy trait. Value borrowed here after move. Is that still the same thing? Location not found in this scope. Okay, so then this gives us, that gives us that. Now, if I want to not do this anymore, if I want to do, well, okay, I think we would need to go look at the quote macro. Is it quote? How do I do the loop? Repetition is done using star or similar to macro rules. Oh yeah, I've been using I've used cargo expand. I just haven't been doing it this time. But that's a really good point, Rizix. Thank you for that. Okay, so if I want to let's try this. We're gonna do a hash, open like that. Then I want to debug. This iterates through the elements of any variable or interpreted with a repetition. Inserts a copy of the repetition body for each one. The variables and interpreter may be anything that, including vec or a pre-existing iterator. Oh, okay, so I can do this. Huh, why am I doing K or V and not K? So if I want to grab out what I'm doing, how does it know? Like we're gonna have like a star, gonna have like the comma here, and I want like arm, but guess I don't remember macro rules of like how to go through something. Well, macro rules I can tell it what it is coming in. Is that? Because like I don't think this will work. Because it's just literally trying to create this again. It's like I can't imagine this is gonna work, and it's gonna yell at me. Oh, it doesn't want this comma? Or just the first of many problems? Yeah, okay. It doesn't like a lot of these things. So how do I tell it to debug through here? Oh, like what it is? Do I just need a semicolon? That? And then are you? Okay, so there is no iterator in repetition. Okay, and then hash, I don't think that will make it work, but we can just try it. Different error. Expected expression found comma. So you don't maybe need that. Not found in a scope. So then basically, if I replace you with that, oh, I don't think it knows how to do this, but what if I try, instead of quotes, what if I do a name : arms? I didn't get any debug out. I was kind of hoping that I would like debug out the thing that I was doing. Let's try putting the comment back in. No, okay. That's definitely not happy. Yeah, it doesn't want this comma here. Let's see. Testing, can't have that. Okay, yeah, so testing isn't running at all. So the debug isn't running. We have arms here, this vector. If I switch you to like just a print line, and I don't do the name : this should print out all of the, okay, yeah, look, location not found in the scope. It's thinking that this is a variable, and it's trying to then actually do that. And that's what which is close to what I want, but not exactly. We can try the cargo expand. So what is that? Cargo plus nightly expand. Which is not helpful. Oh, we have to go into that. So here's the, we're not that. I don't see where it's yelling at us about like a location. I find no. Okay. Well, it would have to be in here then. We have to do that in here. So cargo plus nightly expand.
Reaching the microphone are changed into impulses of electric current.
Okay, so we have this debug. Okay, so here's toString. So we have this function toString match. Here's our testing, and then it's just a new line. That's not what I wanted. And then it returns hello toString. Okay, so that's clearly not what I wanted at all. Because And if I try to do something like, I don't know, like let thing equals name arms, I don't think that that works either. But it does. Look at that. Okay. So I want to come back. Okay, so we've created the name of it.
And now it's available.
So we want to match on this. So what would it be? Match on self. And inside of here, we would do on the left-hand side, it'd be this. Then our fat arrow. And so if we just like add our hello to strings, this could be thing. To string. So we just do that. And that's what we return. So back out to here. This is debug. That match self. That's okay. That's not helpful. Oh, I need a comma afterwards. Each of those. There, okay. So now if I run this, run. And then in here in main, I want to like let the arms. We want to do like a debug of component names, location, to string, like that. We get thing. So we're getting closer. Then back to this, instead of thing, we want this specific arms. So if I did arms to string, location not found is scope, stringify. Arms. Let's try you. Oh, found stir. Okay. To string. Location. That allows me to have a location here. I think this is it. I think we got it. So this gives us what we want to get. So now in here, I can assert. So we debug that, but I should be able to now assert equal. That the string. So we can do location that to owned is the same as component names location to string. That should be correct. So if we run this, it passes. Because if we come back into here and we make this like locations, that should fail. It fails because left does not equal right. So we were able to get it. It was down to the wire too. Okay, so the big thing is we learned in match that we're able to create this loop here, which is very similar to the macro rules. And so we're able to use name to generate the arm, test that, stringify the individual, part of the arms that we care about to string that, and that's what we return. And it works. And just repeat this over and over again. Which is awesome. This is great. So to do the same thing with to stir is actually not going to be that hard. Because all I need is just a to stir. We do the same thing, but we don't to string it. So we could very easily come back to here, add in a function to stir, taking a reference to self. We're going to return a static stir. Back into here. So impl, wait, no. Here, function u. In that, we're going to do the same exact match. Stringify creates a static stir, so we just don't have the toString. So if I do that now, we can come back here and run toStir. ToStir gives us this location, which is perfect. So that's how we can create that. Now there's some other things that we might want to like experiment with, because we can do like intos, but the general idea is that this is how we can create a procedural macro as a derived macro, and then just basically add in whatever details we want to. So it's perfect. Now it is 8:45. It is far past my ending time. Normally I end at 8:15. So I'm going to go ahead and close off the YouTube video portion of this now.